Hi all, hi everyone. Welcome to Data with Arul YouTube channel. On today we will be talking about a text to image model. So this is the one which we are going to see today. So this is called Stable Diffusion. So Stable Diffusion is a deep learning text to image model which was released in August 2022. And if you see, this is the GitHub repository of this, and this is written in Python, and this is how it is working. Okay, so the thing is, like, this particular stable diffusion, this needs a lot of GPUs and VRAMs to process this, because this is a complete image processing stuff. There are other text to image models which are already present, but those are like DALL-E, Midjourney. So it's like they were using their own servers, so it takes sometimes more time to process those images. So our application will be simple now. So what we are going to do is, we are going to create a playground for this stable diffusion. So in this case, like, what we are going to do is, we are going to create an API server which access this stable diffusion. So here what we are going to do is, we are going to feed the prompt, get the response, render it as an image. So this API server, we are going to create it through FastAPI, so that we can have any client to access it through the URL. So this FastAPI allows us to make this service available. I'm not going to put this in internet anyway, I'm going to use it in local only. So yeah, just for the representational purpose, I am putting it in FastAPI. And then apart from that, like, we will be creating a front-end React app. So that this front-end React app will call this API to feed the user input prompt and get the image response. So this is an already existing website. This is called StableDiffusionWeb.com. So this is also not the particular the exact Stable Diffusion's implementation. So this might be built by someone else, because they are putting ads here, right? So this is clearly saying that someone is making it as a kind of a SaaS product. So we can also use it to create a SaaS product. So let's try, like, how their website is working. Okay, so this is what they are telling, all these things. We are not going to create this similar kind of website, but we are just trying to see, like, how this is working first, and then, like, we will also try to implement the same kind of stuff. Okay, so these are the example prompts they are passing. So I am using this prompt. Let's see, a high-tech solar punk utopia in the Amazon rainforest. Okay, so I'm just generating the image. Likewise, this is a text, right? So based on the text description, it will try to generate the images like this. Okay, so this is how the text to image processing will be working. So this is also part of the artificial intelligence. So for doing this, what we need is, we need high-end computing machines and devices. But with the stable diffusion, what happens was, like, this is called stability.ai. Okay, so this is the company who made the stable diffusion in public release from 22nd of August on 2022. Okay, so these are all some kind of user generated images using stable diffusion. Okay, if we are giving the prompt properly, then stable diffusion can generate images like this. Okay, so we want to play around this API. So for that, actually what we are going to do is, when I was trying to find these APIs, okay, so the very first thing what I came to know is like this stable diffusion can be run on your existing graphics card which is present in your machine. Okay, so for because anyway we are going to get the response as an image, and that image we need to process, right? So that image processing kind of stuff should be there. So for that purpose we need high-end GPUs, but the problem is like I have a machine which is having GTX 1650 only. So I found out a problem here, which was part of GitHub stuff. So what they are telling is, they are telling error running float 16 in GTX 1660. So what I just went through it, and then I was trying to understand the code what they are writing here. Okay, so based on that only I have also written the code. So here they are using torch library. This is part of Python torch, and then they are using this library. This is called diffusers library. So inside this diffusers only, this is like diffusion, this is stable diffusion pipeline. So using this stable diffusion pipeline, they are creating a pipe using this pre-trained model. So this is the model dataset. Okay, so using this pre-trained model, they are trying to use this as revision. These are all the parameters, and float 16, and then safety checker none. And he is giving the prompt directly here instead of getting it something like that, and then like using this prompt he is generating the image, and that image he is trying to save. That's it. So this is a simple Python code, and he was facing an issue when he's running this code. So I just took this code and I tried, and I also faced the same kind of issue, and I found a beautiful solution here. So in this solution what he is telling is like yeah, CPU, yeah, he's telling, right, GTX 1660 is the problem. So using a GTX GPU, you cannot run the CUDA loads. So CUDA is the one which is part of NVIDIA's stuff. So I am also not sure, this is part of some graphical processing. Okay, so for that they will be using the GPU. So this one anyway we are not going to use it. So instead of CUDA, so he put the pipe into CPU. So now it will take our CPU load, and it will do the image processing using this output. Okay, so this is how he is suggesting a solution. So based on that, what I did was, I have created the API like this. Okay, so before creating the API, we are going to use this stable diffusion pipeline, right? So this is a pre-trained dataset. For accessing this pre-trained dataset and get the image output, for that we need a API, right? So for that means that like this might be hosted somewhere, and from there only we are getting the this will be executed somewhere. It's not into your machine. Okay, so once we get it, then image processing only is happening in our machine. So for getting that through the API, we need something called API key. So for that API key, we need to go into this website called huggingface.co. Okay, so this huggingface.co is the one which is having the which is actually running the stable diffusion inside their application. So because like stable diffusion itself is a big package and big model, so when we need to execute all the stable diffusion stuff, so this alone will cost around 600 thousands of dollars or 600 millions. I saw somewhere in internet like how much of cost it needs to run the stable diffusion server. So anyway, we are not going to run the complete server of stable diffusion. We are going to use the existing API, which is using the model also from the pre-trained data. So for this actually we are taking up the key from here. Okay, so I have created a new account here, and then here if I go to my profile, inside my profile if I go to settings, here I need to go to access token, and the very first time I need to create a new token. When I am creating a new token, it will just generate a stable diffusion access token like this. Okay, so then I need to copy this token, and I have created a file called auth_token.py. Okay, so here I am pasting this token, because with this token only we are going to access the stable diffusion API. So that's why I am just having this token alone here. And then in my code, this is my API.py. This is the code which I am preparing for this stable diffusion access to create an API backend. Okay, so for this I am just using the local library to import this environmental variable, whatever variable I am setting here, right? So I am just importing it here. And then like FastAPI, I am importing this FastAPI and its response. Same way in FastAPI we have something called middleware cards. This is important to serve this API as a kind of a middleware to get the data to backend. Okay, so that's why we are importing this cars middleware. And then we are importing Torch. Torch is a powerful library in Python, and inside Torch we are importing AutoCast. AutoCast we didn't require actually. I just disabled it. I will tell you why I used previously. And then this is the diffuser stuff. So this is where we have this stable diffusion pipeline. Okay, so with this only we are going to call the API. So this is like a kind of an API which will be calling another API. Okay, so this is the pipeline, and then like this is regular IO imports, base 64. Anyway, we need to do some encoding and all, that's why we are importing it. Okay, then we are making the app as FastAPI. Okay, so this is the class of FastAPI, so I'm just calling FastAPI stuff. And then like in this, actually I have imported this course middleware, right? So for this course middlewares, I need to allow these credentials. I need to set the origins as any, methods as any, headers as any, because these are all the restrictions over there in the middleware. Okay, so I can command this code. I am not using the CUDA. I just copy pasted, that's why it is here. Anyway, it is not serving any purpose. Device is not CUDA actually now. So what I am doing is like I am just passing this model ID. So this is the model ID which we are going to pass as the parameter for this particular API. Okay, so I am going to call this stable diffusion pipeline class. Inside that, from pre-trained is the method. So this one I need to install. So this is like a kind of a pip install only. So I need to install this diff users. So pip install diff users will install this one. Okay, after that I need to pass these parameters. So this model ID is nothing but this one, computer vision stable diffusion v1.4, and then the revision fp16. These and all are the default parameters. And in this torch d type, previously in the GitHub I saw it as float 16, but that error resolver, that guy, he is suggesting to change it to float 32. And then we are using the authorization token. Anyway, this is the authorization token we have stored here and we have imported in the code also. So what it does was, it will call this method which we installed, and using this method, when we are passing this parameter, it is again calling the API, stable diffusion API, which is present in that Hugging Face. Okay, so in that API it will try to establish a connection. Okay, so now this pipe will have the connection. So in this pipe, again what we are doing is we are enabling a sequential offload, CPU offload, so that the load processing, the image processing, whatever resulting image is coming in, so that image will be processed in our CPU instead of GPU, because we don't have the CUDA support in my machine. Okay, so and then what happens was like this is where I am making it as an API. So I just enabled an annotation this one anyway we already set it as a FastAPI, right? So with this annotation I am enabling it as an API, and here I am defining a generate method. So this is a default method. So in this method I am passing a parameter called prompt. So in this prompt will be a string type. Okay, so this prompt is the one which is going to serve as my input. So whatever I am typing there, I need to change it as an image, right? So that typing stuff, that input stuff will be passed to this prompt. Then again, for creating an image, okay, the result will be an image of this pipe call. So in this pipe call only I am passing this prompt. So now only it is going to establish a connection with the API and get back the response. So here prompt, and then this is guidance scale. Guidance scale is nothing but like a kind of a temperature setting for this prompt to work in the model. And then again images of 0. So in my, if you see this Stable Diffusion web, we are getting 4 images, right? So I just need only one image. So this is the first image. So for getting that first image, we are putting this. So I am going to save it a local copy also of this image. So that's why I am using this image.save, and I am buffering this image and I am streaming it into this image str. Okay, so that it will be encoded it into base64 format. So again in my response, in the sense like whenever this API is getting called, right? So whoever the client might be, it might be a Node.js application, it might be a React.js application, it might be any application which is calling this API, that application will get this response, this image string as the response. So this image string media type will be image or PNG likewise, so that the system will understand that okay, the response whatever we are getting an image likewise. So this we can do it in Postman also, but yeah, let me show that in the web itself. Okay, so once my API is done, then what I will do is this one, for this FastAPI actually I used something called UVCon. Okay, so this UVCon is the one which I have installed. So npm install UVCon will do the UVCon installation to enable the FastAPI stuff. Okay, so this is the command which I am going to run now. So UVCon API is my application name and app is the default one which is telling that to run this FastAPI. Okay, then if I hit enter, now it is asking me to, okay, it is finishing the shutdown. So it is telling that UVCon is running on this one. Okay, so FastAPI, if I try to open this, it will tell something like that. So I need to pass some parameters. So I need to pass like slash and then docs likewise. So this is the default URL to access the FastAPI Swagger UI. Okay, so using this Swagger is nothing but like a kind of a request response stuff. So using this we can test the FastAPI how it is working. Okay, so I'm just pressing an enter, and here this is generate, right? So this get generate is nothing but here we have defined the generate. So here we have defined this one as generate. So under that we have only the prompt. So that prompt will be here. This is the prompt, right? So this is where I am passing the request. So what I need is I will be trying out the same thing what we are using here. Okay, so I'm just trying to execute it. So when I am executing it, what it does was, yeah, here it is starting the processing. Okay, so what it does was it will call out this API first, using our authentication key to that Hugging Face, and there this particular model ID will be executing my query, and based on that it decodes the image and it sends back to us in the name of response. So that particular response we are storing it into this variable called image, and that image again we are saving it in the name of prompt. Okay, so these response parts whatever we have coded, that will be sent back to the one which the API is getting called. Okay, let it load. So my image name will be this prompt, as well as it is having the extension of .png. That's how we are expecting the result. So that result should be appearing here. Now if you see, this is the prompt I have passed, right? A high-tech solar computer behind the Amazon rainforest. So this is the one our model has been outputted. Okay, so I am just passing a text one, and based on that it is having the ability to understand it and decode it and trying to give us a response like this. Okay, so this is how I made the API. And now if you see, the API is live, so it is running on my Unicon server, that is my local server, and this is giving a successful response. This is the request URL. Okay, so I am passing this as prompt. So this one, with this one, if I have a front-end application, okay, if I build a front-end application, then with that what I can do, what I can have is, I will get the image and I can make my stable diffusion as like a kind of a SaaS product, like how this is getting built, right? So if I give something here, and then if I generate image, it is giving me 4 images, right? Instead of giving me 4 images, I will take the very first one of that image and I need to display it there. So how I am going to achieve that? So for that I have built something in the React. Okay, so I will be showing that code also. So this is the client code which I have written. So inside that client code, it's nothing but I just did a npm create react npx create react app, right? So it will automatically generate all the node modules and something like that. So inside that, actually I am using Chakra UI. So Chakra UI is nothing but it is also kind of uh, React library which will be helping me to do the fast application development. Okay, so and I am using Axios also to make the web server and asynchronous stuff to be working. Okay, so this is the application which we write to serve as a kind of a front end. So what we did was like anyway, this index.js is nothing but it will be calling this app in React, and then this app.js will have everything. So inside that, this is the first one. I am just importing everything like whatever I need for this application, and then this is where I am doing the call to the API. So how I am doing is I am just passing this one dynamically. So this is the prompt. So this prompt is an asynchronous prompt. Okay, so yeah, this one is a update image, update loading, these and all are part of this Chakra. Okay, and then like in my return only I will be writing this one is the Chakra provider, and inside that container I am just putting my heading as Stable Diffusion, and then again some blah blah text, and then this is the one, this is where the exact model is. So we saw that, right? Comfy space slash Stable Diffusion. So with this model only this particular stuff is running, that is run by Stability AI and then Runway ML. Okay, I'm just giving the GitHub repo, and then like when the user is, yeah, this is the text box. So inside the text box we are putting the prompt as the value. So this prompt we are passing here, right? So this will be passed to the backend likewise. And then like on change event we are putting an event to update this. So whenever something is getting typed here, so that will be updated to this value prompt, and then this will be a width of 350 pixel. So that will be my input text box, and then my button I am just putting it in a yellow color, and then this one will be having this generate. Okay, so this one will call the action generate prompt. So this generate prompt is here. This is the generate and this is the prompt. Okay, same way for the loading I have something for this box shadow image, so that will be showing that whether the application is loading or what. Okay, so let me run this. So I am inside the client code. I'm just putting npm start. So the same header, and then this is the text, and this is my text box, this is the generate button. So when I am clicking this, it is going to hit my FastAPI and it will provide me the image here. So that's how we are designing it. So I will be taking some prompts from here itself. An insect robot preparing a delicious meal. Okay, suppose if I am generating it here, so this is the output from Stable Diffusion existing web application. So this is giving 4 images for me. So I need an apt image also to be getting selected. So I'm just putting the same prompt here and I'm clicking generate. So what happens was it is going to hit the local API which I am running here. So yeah, once it is done, then again it is trying to generate the image. Okay, so once the image is generated, then I can see the image here also, as well as it should be present in here also. So this is the loading animation which is happening here. And it is taking some time because anyway it's calling an API and doing all these things, and that way everything is a free stuff, right? So based on the CPU, GPU and the resource intensiveness, it is going to give us something properly. So the main purpose of this is to showcase the ability of Stable Diffusion, as well as like how we can play around in a text to image processing stuff. So text to image processing stuff is like a kind of a advanced AI stuff, means that like it is semantically understanding what you are asking, and based on that it is giving you an image response. See, it looks somewhat apt, right? Let me see what I got in the output. Yeah, this is how we are getting the output. Okay, so that's all for this video, guys. So if you like the video, please share it to your friends, as well as please do like, share and subscribe this video, and we will see you in the next video. Thank you so much. Bye bye, guys.